Okay, so in this video, we will look at the general guidelines and how to construct a histogram. Namely, given a set of numerical data, how many intervals should we construct, and how do we construct them? Now, a histogram is basically just a bar graph where you're not given initially natural categories or intervals. If you have all integer values, if you think of the previous videos with just ages of people, we didn't have to really construct intervals as they were a natural choice, right? There was people in their teens, so from 10 to 19, people in their 20s from 20 to 29, and so forth. But sometimes you have data that is not as nice. You could look at prices, so you have decimal values, and so there's no natural set of categories. You have to construct them. So here's how to construct it, and in our next video we'll consider an example of these general guidelines. So suppose we have a sample of n values, x1, x2, up to xn. So you can imagine that those values are values with decimal places, so they're not nice integer values. Okay, the first question is, how many intervals should we use? Well, our sample size here is n. So the number of values observed, and k will take to be the number of intervals that we will construct. And there's a lot of different ways to find k as a function of n. We'll take the simplest way. As a general rule of thumb, if you have n values, you should need approximately square root of n intervals. And this really is a general guideline, but it's actually a pretty good one. That's the one we're going to use. Okay, now that you have this, then the question is, how do you set up your intervals? You say, okay, fair enough. Given n data values, I'll use approximately root of n intervals. How do I construct them? Well, imagine that you have here your axis for the x values. Well, you will naturally start with the smallest value, whichever one it is in your sample, so x min, and you'll end naturally at the largest value, x max. The question is now, well, how do we subdivide our range from the smallest to the largest value in k intervals? We'll naturally take intervals of equal length. Well, if you think of it, let's first compute the range, so the length of our interval. So the range is the maximum x value minus the minimum x value. And all the range, of course, is the length of this original big interval. And now think of what we're saying. We want to subdivide our big interval from x min into x max into k intervals of equal length, right? So we'll use w for the width of or the length of one interval, length width, same thing, of a single interval. And now, as we've just said, well, we want to subdivide the longer interval, whose total length, width, is the range, and we want to subdivide this into k intervals of equal length. And so each interval will have width, length, the range, divided by k. And that's it. And now if you think about it, we can then construct the endpoints for each of our given interval. So we have the width is the range over k. The range, as always, is the maximum value minus the minimum value. And as a reminder, n is simply the sample size, so k is approximately the root of n. Of course, root of n will most likely not be an integer value, so you can round up or down at that point. If you're off by just 1, it doesn't really matter, as this is really more of a general guideline than a precise equality. Given n values, we want roughly square root of n intervals. And now, think of it. You start with your x min, and you add w to x min, so you get the right endpoint of your first interval, so x min plus the width, and you keep adding w every time. So add w again, at the right point of your next interval, add w, add w, add w, add this, well, we have k intervals, so add this k times, and then you'll get back to x max. And then you'll get your k intervals, where each has equal width, being w. And that's it. This is your general guideline on how to construct your intervals for a histogram. And then you will simply look at your raw data and figure out for each interval how many values are contained into this interval, which will give you the frequency for every given interval. One thing can be noted, as this is nothing but a general guideline, sometimes to make your endpoints a little nicer, you can deviate a little bit from your x min and the value of your width. And you'll see this when you go through examples. Suppose that your x min was, say, 9.97 and your width was 7.03. Then you could say, well, instead of starting at 9.97, I'll start one below, so I'll start at 9. Instead of taking a width of 7.03, I'll just take a width of 7. So then I'll just do 9 plus 7, 16, plus 7, 23, and so forth. So you can deviate from your x min and your width as long as you stay close enough. Because again, these are simply general guidelines. As long as you stay close enough to the minimum value and to the actual width, you'll have a histogram that looks pretty much the same as the one you would get if you follow these guidelines to the letter. And that's it. So in our next video, we'll consider an example of these guidelines.